So we're going to be looking at linear graphs. So linear graphs are obviously straight lines. So when we have a linear graph, it means a straight line, and we will come across these next year when we look at equations with the straight line, and there'll be points of interest that we need to know about. So mainly, which you've done before, so we'll be looking at, say, the intercepts. The y-intercept becomes important, and also we'll also look at, say, the slope, or which is, we know, is the gradient of that line. So we need to just refresh and go over this stuff to make sure we know. So this, at the beginning, we're going to practice drawing straight lines and doing the graphs, and to understand how they are formed. So when you have a straight line, you obviously get an equation. So here, down here, they're asking me, here's the equation, and they want us to plot it on the graph. So what we could do is we can have a table of values, and what we can do when x is a certain number, we can find out what y is. So if you look here, we're going to use the formula. So the formula is y equals 2x minus 1. So in this, when we're trying to find out this number, we're going to put in -1 because that's what they're saying x is. So we've got 2 times -1, which would be -2, minus another 1, which would be -3. So we're saying when x is -1, y is -3, and we can draw the point on the graph. So, and then you can pop in all the rest. So we know this one, when x is 0, y will be -1. And this last one, if this is the formula, when x is -1, y is going to be 1. So we can plot those points in. So when x is 0, y is -1. When x is 1, y is 1. And you can see that if you get your ruler out, those points will all line up on a straight line. And there you go. You can draw your equation. All right. So what you're going to get asked next year a lot is to draw this equation. So you'll have an equation, and they'll say put it on the graph, like draw it on here. So the best way to say we were drawing this equation, if I was asked without doing a table of values, I was asked to draw this line onto that graph. A good way to quickly sketch it is often pick, say, 2 x values. So I'm going to pick the first one and the last one along that axis there, and sub them in and get 2 points. So we know when x equals 0, we saw that y equaled -1. So we would have that point here. And then if I subbed in the 5, say when x is 5, that last point, I'd see that y is, it'd be 9. So you go... So it'd be way up here, sorry, it'd be way out there. But anyway, so often that's what you're going to have to do next year, okay? Just get the first and last point, sub it in so you can draw the line that they're asking you, okay? We need to know how to do it on our calculators as well. So we're going to have a look at that now. So grab your calculators. Okay, so we're also going to look at now we're going to look at the slope of the line. So as I said, we're mainly next year, what you're going to see is you're going to see just this part of your graph. So where you probably will have x and y. We don't normally, we don't deal with the negatives, because in practical applications and in general mathematics, we're normally talking about, say, like money. We don't have the minus money. We might be talking about rates of maybe, or how many people and things growing up. So our main axis is we're mainly looking along here. So we're going to have this straight line, as I said. We're going to have a straight line, and our points that we're going to be looking at mainly will be here, which is the y-intercept. That's always an important point, because we know it's when x equals 0. So we're saying what is it to begin with is generally that. And the other thing we'll look at is the slope. okay? Now the slope is like the gradient. Well, it is. It's just another word for the gradient. So, and it means like how steep that line is. So if you have a look, if you have a line that, so say we have this, and then we have another line, straight line like that, this is a bigger gradient. This one's got a bigger slope, yeah? And this is also, so this and that. So another word that the slope could be gradient. It can also include a rate. So a slope or the gradient is how quick is it going up by a certain amount. So it can be referred to as a rate as well. All right. So we have a few formulas that we have done in the past. So we normally call the gradient M. So the slope is what we'll probably refer to it a lot now. And we know there's two formulas that you can use. You can use rise over run, or you can use the y2 minus y1 over x2 minus x1. So what that means when you get the y2 is that they give you, say, 2 points. So this could be point 1, and it'll have an x and y value, and this could be point 2, and it would have an x and y value. So say I made them up and I said this was 3,6 and this was 9,18, okay? So if I went to find the gradient of that example there, I would say, all right, y2 is 18, y1 is 6, over x2 is 9, minus 3. So we end up with 12 over 6, which equals 2. So this one would have a gradient of 2, okay, if I made that up. All right, so when we go up, we can say we've got a positive slope. So that means the M value, yeah, or that will be a positive number. Okay, if we have on the next page, our graph is going down, it's a negative, so the M number will be a negative number. So say for an example of that would be like if you have negative 2x plus 1. So this number here is the M, or the slope, so you can see it's negative. Now when you have a 0 gradient, it's flat like this, so a horizontal line. So you might want to write next to that's a horizontal line. And an example of that would be you have y equals, it'll just be a number. So I might say y equals 3. So say that was 3 there. So you can see there's no x number in there, no number with an x in front of it. That's a 0 gradient. And when you have here, the vertical line, that's when the gradient M is undefined. And an example would be you'd have, say, if that was 2, the equation would look like this, an x equals 2, something like that. All right. So here they're saying find the slope of this line that passes through. So if we've been told the slope, that's like the gradient. I'm going to use that xy, y1, x2, y2. I'm going to use that formula. So I know the slope can be found by doing that formula again. And I'm going to say, so 8 minus 4 over 4 minus 1. So I get 4 over 3. So that's my slope. You don't have to change anything, just leave it like that, 4 over 3. Okay, if you change it to a decimal, that's okay too in general maths. So for that one, it'd be like 1.33 or something. Okay? But you can leave it in a fraction or whatever you... Okay, so let's have a look at this one. It says find the slope passing through these 2 points. So once again, you can just call them... It doesn't matter which one you call point 1 and which one you call point 2, as long as they're paired together. So if you're calling 1 x1, its pair has to be y1, okay, its partner. So if we go to find the slope, we can use that formula again. Okay, sorry. So we've got, y2 is 2 minus 10, good, over 4 minus 0. So we get negative 8 over 4, so negative 2. So this graph would look a downward one. Okay, find the slope passing through the points, and using the formula for the slope of the line, give your answer correct to 2 decimal points. So it's just worded out. We can still do exactly what we're doing now. So I'm going to write the formula out because they've asked me to show that, so I better do that. So I've got 2 minus 7 over 4 minus 1. So I get negative 5 over 3. So it says the 2 decimal places. So what's that going to be? Negative 1.67. Okay.